Hello, so in this video, I'm going to go over the answers and the grading for midterm 1. So if regardless of how you did on the midterm, it might be helpful to go over it and see what the right answers were, where you went wrong, and stuff like that. So I'm going to start with the multiple choice. Okay. And question 1 of the multiple choice, the first 3 questions you had to select all the valid answers. So the first 3 questions were quite a bit trickier. Question 1 on the midterm says, which of these are subsets of curly bracket 1, 2, 3? Curly bracket 1, 2, 3. So what we're talking about here is on the number line, we're talking about the numbers 1, 2, and 3. And the curly brackets mean I'm literally thinking of only the number 1, only the number 2, and the number 3. So the number 1.5 is not there. The number 2.5 is not there. There's nothing between 1 and 2. It's not an interval. It's the curly brackets means just the set 1, 2, 3. And your options are, option A is a special symbol, the empty set. Option B is the number 0. So curly bracket 0 means just the number 0 on its own. Option C was the interval 1 to 2. So all the numbers between 1 and 2, including 1 and 2, is option C. Option D is the numbers 1 and 2 only, no numbers between them. And that's because it's got curly brackets. And option E is everything between 1 and 2, not including 1 and 2, the round brackets. So this was really a question to see if you understood the difference between the curly brackets and the round brackets, and things about sets. So what are the correct answers? Option A is definitely correct. The empty set is always a subset of everything. So the empty set is always a subset of any set no matter what. Nothing is a subset of anything. So that's correct. B is the number 0. The number 0 is not contained here. Number 0 is off over here. So, the number 0 is not part of 1, 2, 3. So that's wrong. I'll tell you, out of C, D, and E, the one that is correct is option E. Sorry, not option E. Option D. Option D. This one is correct. So this is the numbers 1 and 2. Option D says the numbers 1 and 2. 1 and 2 are part of 1, 2, 3, right? That's why option D is correct. Option C and E are both wrong. Option C and E are both wrong because they include numbers that are in between 1 and 2. So for example, let's do option C. Option C is everything between 1 and 2, including 1 and 2. And that includes numbers like 1.5 or 1.7. A whole bunch of numbers are included that are not part of the original set. They're not part of 1, 2, 3. And that is why these things are not subsets of 1, 2, 3. They include things that are not there. So because they include things not in 1, 2, 3. For example, 1/2, therefore not a subset of 1, 2, 3. So these ones are both wrong. Okay. So a lot of people, I think, on the actual exam selected option C, and that was probably because on the practice test the question was about what is a subset of the closed interval 1 to 2. So if you were confused by that, make sure you check it out. This question was by far the question that the most people got wrong on the exam. And I think the reason that so many people got it wrong, I was looking through the notes to try to figure out what happened. And you have to go all the way back to January 11th. The first class of the course is where we did this. It was exercise 1. The proper subsets of 1, 2, 3 are, and we listed all the proper subsets of 1, 2, 3. It was the very first question in the course. So maybe it was so far back that people didn't remember or were confused or didn't study right from the practice midterm and didn't understand what was going on. So in the end, because so many people got it wrong, I decided that I'm going to count this one as a bonus question. So this one will be bonus. So it didn't count against you. If you got it wrong, it doesn't count against you. If you got it right, or you got half marks, if you selected 1 out of 2 of these answers, you got a half a mark, then it's bonus for you. It doesn't count against you if you got it wrong. Okay, let's look at the next question. Which of these is true about the function f of x equals 1 over x? This is another one that we talked a lot about in lecture about vertical asymptotes and what they mean and what they don't mean. The function f of x equals 1 over x is this guy, this function that looks like this. It goes like that. And this was the classic example of having a vertical asymptote. So when we learned about vertical asymptotes, this is the example we had. So it definitely has a vertical asymptote. And it's not defined at 0 because you're dividing by 0. So you have 1 over x. When x equals 0, the whole thing is not defined. That is also correct. These other two, f of 0 equals infinity and f of 0 equals minus infinity, these ones can never be correct for any function because infinity is not a number. The infinity is not a number. These are not right. This one was actually pretty well done. This one, most people got this one right. So this one, people, I think, understood. I will also say I'm doing version A right now. In version B, it had the exact same questions and the exact same options, but in a scrambled up order. So the questions were the same for the multiple choice. All right, question 3. Question 3. Let me see how many people got question 3 right. Yeah, question 3 was pretty well done as well. Not too bad. Maybe middling. Question 3 is about what is theta if the sine of theta equals a half. So sine of theta equals a half. This should have been on your formula sheet for the special angles. The special angle where the sine of theta equals a half is theta is 30 degrees, which is also known as pi by 6 radians. So pi by 6 is definitely a right answer, but there are more than one possible answer. And what you have to know is what we talked about in periodic functions is that the sine function is 2 pi periodic. So if you start at some angle and you add 2 pi, you get back to where you started. And you can see this sort of visually. So if you have some angle here, pi by 6, and then you go all the way around the circle one more time, you do 2 pi plus pi by 6, you get back to where you started. So the original angle was pi by 6, and 2 pi plus pi by 6 is going all the way around. That will have the same sign. It'll have the same cosine. It's the exact same position on the circle, and so it represents the same trig functions. So from periodic functions, we know sine is 2 pi periodic. 2 pi plus pi by 6 is right. The other two are not right. So if you go around only pi radians, then it turns out you're going to have negative of the angle. You didn't need to know that. But pi, this is pi by 6 plus pi, is this one in quadrant 1, 2, 3. So that's not correct. And 2 pi is the same as, 2 pi by 6 is the same as pi by 3. The sine of pi by 3, I think is square root of 3 over 2. That's not correct. Okay. So those are the three multiple answer ones that were quite a bit trickier. The rest are just select one answer. Question 4, express the set minus infinity to 2 union 3 to 5 using inequalities. This question was taken directly from the Mathematized homework, and the right possible answers are, you're supposed to recognize that minus infinity to 2 with a closed bracket at 2 means x is less than or equal to 2. So it could be this one, or it could be this one. Maybe I shouldn't draw a check mark. Let me write could be. And this one could be. And these two are both definitely wrong because the less than sign here is not correct. So x is less than 2 would be a round bracket at 2. We have a closed bracket. C and D are definitely wrong here. Okay, so we're on options A or B. And one of them has an and one of them has an or. And I think this is one thing that a lot of people struggled with. So quite a lot of people got this one wrong, even though it was from the homework. If you draw this on the number line, the reason you might think it's and is because you have two sets. You have everything less than 2. So on the number line, less than or equal to 2. Here's x equals 2. And you have everything between 3 and 5. 3 and 5. Here's x equals 3, and here's x equals 5. So that's what the set looks like. It's got two chunks, the chunk of stuff less than 2 and the chunk of stuff between 3 and 5. And if you're just talking like plain English language, you would say, I have two things. I have this and that. So it's tempting to use the word and. But if you're thinking math in terms of mathematical logic and in terms of what the words and or mean for these x values, the correct answer is B, that it is or. It is x is less than 2 or x is between 3 and 5. And really what's going on here, if you have any x value somewhere in here, like you have, let's say x equals 4 is a good example. X equals 4. X equals 4 is between 3 and 5, but it is not less than 2. it is only one out of the two things, right? X equals 4 is somewhere in my set, and it satisfies being between 3 and 5. It does not satisfy being less than 2. If you were going to use the word and, it would mean it satisfies both. So the word and is intersection, and it means both, which is intersection. We are not doing intersection here. We are doing union. So because this is a union, it's an or. That's the correct answer. B. B is the correct answer. So I think if you got this one wrong, you probably were not paying attention to what the difference between union and intersection are. Maybe you understand them in terms of pictures or something, but in terms of mathematical logic, we're talking about which of the statements are true, and only one out of the two statements has to be true to be in the set. That's an or. That's why it's B. Okay. Yeah, so this one was pretty poorly done. A lot of people got mixed up and chose A, or otherwise messed up C and D. Okay, question 5. The function x squared plus x cubed. This one was really well done. The correct answer is that this one is not even and not odd. So it's not both, it's not odd or even, it's not even or odd, it's neither. And one way you can see that is you could put in f of minus x, and f of minus x would be minus x squared plus a minus x cubed. And if you simplify that, you would get x squared minus x cubed. So an even function, when you plug in f of minus x, you get back to the original function. So it would say f of minus x equals x squared plus x cubed, which it doesn't, so it's not even. And an odd function, you would get a whole negative sign in front. So you would get f of minus x is minus x squared plus x cubed, which it isn't. So it has a negative sign in front of the x cubed, but no negative sign in front of the x squared. And for that reason, it's not even, it's not odd. And in fact, most functions are not even and not odd. Even and odd functions are sort of really special functions that have a lot of symmetry. Not even and not odd. Okay. That one was pretty well done. Question 6. Oh, no, I'm off by one. Okay, wait, hold on. Let me back this up a bit. Okay. I'm looking at how many people got each one right. And question 4 was pretty well done. So around most of the people got this one right, like over 50%. And question 5 was the one that was poorly done. This one was poorly done. This one apparently was hard. So there were some like this on the Mathematize, but maybe people saw x squared and x cubed and remembered from class that, oh, that's even and odd. And individually x squared is even, and individually x cubed is odd. When you add them together, it's not even and not odd. So question 5 was the hard one that most people got wrong. Okay. Question 6 was pretty well done. So it's the angle 8 pi by 3. 8 pi by 3. And you had to figure out which quadrant it's in. So one way some people did this was with a calculator. Take 8 pi by 3, convert it to a number, and then look at where that is on the circle. That's totally valid. Here's how I would do it without a calculator. So 8 pi by 3, I'm thinking in terms of going around the quadrants, and 180 degrees is a pi. So 180 degrees is pi. 360 degrees going all the way around, that's 2 pi. And so going all the way around, and then you keep going, that's a 3 pi. Right, so pi is 180, 2 pi is 360. What's the next like skateboarding trick? A 540, I guess, is you do a 360 and then 180 more. And the number 8 pi by 3 is a little bit less than 3 pi, right? Because 3 pi would be 9 pi by 3. So just as a fraction, 8/3 is a little bit less than 3. And it is bigger. It's definitely bigger than 2 pi. 2 pi would be 6 pi by 3. That's 2 pi. And it's even bigger, actually, than 7 pi by 3, which would be 2 pi plus pi by 2. So it's a little bit less than 3 pi. It's more than 2 pi plus pi by 2. So 2 pi is the pink going all the way around. 2 pi plus pi by 2 is this. 2 pi plus pi by 2 is 7 pi by 2. Would be going all the way around and then 90 more degrees. And the angle we're looking at, 8 pi by 3, is somewhere between that purple and that blue. It's less than 3 pi, but it's more than going all the way around plus 90 degrees. It's a little bit more than 7 pi by 2. And that means it's somewhere in this quadrant, right? The angle we're looking at is not fully 3 pi, but it's more than 7 pi by 2. It's 8 pi by 3. Okay, so where is it? It is in quadrant 2. Quadrant 2. Quadrant 2. Okay. Okay, and actually, now I'm doubting. Make sure I did this right on the spot. Here's the answers I did earlier. Yeah, it's quadrant 2. And again, you could have done it with a calculator or a number of different ways to do this one. Another common way to do it is you subtract off 2 pi, right? So the angle 8 pi by 3 is the same. It's the principal angle for this would be the same thing minus 2 pi would be 2 pi by 3. So by subtracting 2 pi, you just have the angle 2 pi by 3, and you figure out where that is. It's in quadrant 2, and subtracting 2 pi doesn't change which quadrant you're in. So that's the principal angle way of doing it, which was on the homework. Either way, the final answer is quadrant 2. I will say on the other version of the exam, I think they had a different number. Let me go to the other version of the exam, which is here. Yeah, on the other version of the exam, they had 10 pi by 3. 10 pi by 3. So very similar idea. 10 pi by 3 is a little bit more. 10 pi by 3 is a little bit more than 9 pi by 3, which is 3 pi. And so if you draw the whole thing going all the way around, 3 pi is going all the way like this. And it's a little bit more than 3 pi for 10 pi by 3. And therefore it is in quadrant 3. So the correct answer on the other version of the exam was quadrant 3 for that reason. And once again, many ways you could do this problem. Okay. This one was pretty well done. So this question was pretty well done. Let me scroll over my list of questions. Okay. Question 7. True or false? The function f is 1-to-1. And so here's the function f and the function g. This was a really well done one. Almost everybody realized the function f is not 1-to-1. It is not 1-to-1. Why is it not 1-to-1? Because it has the same number appearing twice. So it's equal to 4 twice. When x equals 3, it's equal to 4. When x equals 4, it's still equal to 4. 1-to-1 functions are never equal to the same value more than once. And therefore, the function f is not 1-to-1. So that one was really well done. Question 8. What is g inverse of 5? G inverse of 5. So this one, right around half the people got it. You have to know how to do inverse functions, and specifically from a table, which was a homework question. And there's something similar on the practice test, doing it from a graph instead of a table. But g inverse of 5 means what value of x gives g of x equals 5, right? That's what we're trying to solve for. So g is a function, it inputs x values and outputs something. G inverse is the reverse. So g inverse of 5 means what do you have to input to get 5? And the easiest way to do that is look at the table, notice the value of 5 for g of x. So when g of x equals 5, what is x equal to? It's this value up here. It's this value up here, so that was 4. That's how you would do this problem. It's 4. And again, I'm on version B of the exam right now. In version A of the exam, what is g? The very similar question. It's g inverse of 2. What is g inverse of 2? You find where is g equal to 2. That's right here. And what is the x value for g equals 2? It's 3. It's 3. So g inverse of 2 is equal to 3. Okay. Okay. All right, that was question 8, which about half the people got. Question 9 was really well done. What is g minus f of 4? G minus f is a new function you get by subtracting f and g. So g minus f of 4 is equal to g of 4 minus f of 4. G of 4 was 5, right? Looking at this table. And f of 4 is 4. So 5 minus 4, which is 1. So that was really well done. That is correct. These ones are all wrong. And in the other version of the exam, I think is very similar. Same question, different numbers. G minus f of 2 is 3 minus 1, which is 2. So this is g of 2 is 3, and f of 2 is 1. 3 minus 1 is 2. Okay. All right, last but not least, the last question of the multiple choice was f circle f of 2. You had to know that f circle f means composition. So this means f of 2. And there was a question just like this using graphs on the practice test. This one is using tables. What is f of 2? F of 2 is 3. So f of 2 is f of 2 equals 1. F of 2 equals 1. So this is how you got to do this. Just go layer by layer. F of 2 equals 1 from this part of the graph, or of the table. And last but not least, f of 1 is equal to 3. So f of 1 equals 3. So that is the correct answer by doing the composition layer by layer. So you had to know what f circle f means. It means f of 2. And then you had to know how to do that kind of thing. Just go working from the inside out, layer by layer. So it's 3. And I think this question was exactly the same in both versions of the exam. Yes, it was. F of 2. Okay. Last but not least, you could do the bonus, which is very similar to question 10. So question 10 was not very well done. Most people did not get question 10. Maybe compositions are tricky, or you didn't practice this kind of skill on the practice test with the graph. Question 11 was question 10 on steroids. What is f of 2? So we got many circles here. That means you're going to be doing f of f of 2. So it would be a really hard question where you have to peel back layer by layer for 100 layers, but there is a trick that makes it very simple. So if you tried this one, maybe you noticed the trick, which makes this whole problem very easy, and it really doesn't matter how many f's there are. You can do it by just doing the first few. So f of 2, after one f of 2 was 1. So f of 2 is equal to 1. That's what we just did over here, what I underlined. F of 2 is 1. And I can close this, I guess, to make a little more real estate here. Okay, f of 2 was 1. And f of 2 was f of 1 was 3. That was in question 10. And f of 2, that would be f of 3, right? So doing 2 layers would give you 3, and you do one more f, now you have f of 3. Let's look at the chart. F of 3 is equal to 4. So that equals 4. And once you've done this, once you've realized that by going 3 layers in, you have 4, now the problem becomes easy. And the reason is, if you do one more layer, so let's do one more layer, one more layer. Here's the one more layer. F of 2. All this stuff in the middle we said was 4. So this is f of 4. And f of 4, looking at the table, f of 4, when x equals 4, f of x is equal to 4. And now you should realize something. Maybe I'll do one more just to help you with it. F of 2 was f of 4, which is 4. So if I do one more f of however many f's of 2, that will be f of 4, right? Because all the stuff inside we said was 4. We're applying f one more time. It's f of 4, and that's still 4. So this is the thing about the function f. Because f of 4 equals 4, and because we eventually got to a 4, right? We went 1, then 3, then 4, and from everywhere after that, it's always going to be f of 4. F of 4. And so, the first one, the second one, and the third one are different. But after that, no matter how many f's you have, the answer is always 4. The answer is always 4. So the answer to this question is 4. Is 4. And yeah, right around 35% of people, around a third of the class got that one right. And hopefully realized the trick, or otherwise was lucky in guessing. So this kind of thing in math is called a fixed point. This is a fixed point. And it's called a fixed point exactly for this idea that you can apply f over and over again. It doesn't change. It's fixed. It's always 4. So that was a fun trick. You didn't have to do too much work. You just had to take what we did in question 10 and apply f 2 more times to realize the pattern. Okay, that's it for the multiple choice. And that was the same in options A and B. Questions 10 and 11 were exactly the same in both versions. Let's move on to the short answer. And I will open up the spreadsheet that has how people did on the short answer so I can comment on that as well. Okay. Short answer. Yeah, the short answer was overall much better done than the multiple choice. So people did better on the short answer than the multiple choice. Maybe the part marks helped you out. Question 1 was really well done. We did this function in class, x minus absolute value of x. Basically, the only thing people screwed up here was misunderstanding what absolute value means, or screwing up a negative sign somewhere, or getting in their head about what is absolute value. Yeah, let's just do it. So f of minus 5, x. So here, x equals minus 5, and the absolute value of x is the absolute value of minus 5 is just 5. And we are told to do x minus the absolute value of x. So f of minus 5 is going to be minus 5 minus the absolute value of minus 5 minus another 5, right? So the absolute value of negative 5 is just 5. So it's minus 5 minus 5, which is minus 10. Minus 10. So the only way to screw it up really is to get confused by all the minus signs going on. We did this exact example in lecture, and that's why I did it here. So I think even at the 230 class, somebody even said like, oh no, it's negative. It should be 10. But it's negative 10. That's the right thing. Okay. And the other version of the exam, I think, had the exact same thing, but they had negative 3 instead of negative 5. So same idea. The final answer here is negative 6 instead of negative 10. It's twice the input. All right. And what about f of 5? So in this one, x is 5, and the absolute value of x is the absolute value of 5, which is 5. So x is 5, the absolute value is 5. What is f of 5? It's 5 minus the absolute value of 5, also known as 5 minus 5, which is 0. So this one, f of 5, is 0. So some people switch these and stuff like that, but almost everybody, I think, got at least 1 out of 2 here. Most people got this one correct. Okay, next up, question 13. Express each set in either set notation or interval notation as appropriate. The first two, we're asking you to simplify this kind of thing. So this means the set of all x such that x is a natural number. That's what this means. The set of all x such that x is a natural number and x is less than 4. So we're talking about the natural numbers are starting at 1. 1, 2, 3, 4, 5, ... Those are the natural numbers. And we're talking about give me all the natural numbers that are what? Okay. Oh no, we've lost where we were. Okay, here we go. Give me all the natural numbers that are less than 4. Which numbers are less than 4? Well, it's 1, 2, 3. So the answer to this question is 1, 2, 3 as a set with curly brackets. All the numbers that are less than 4 and also a natural number. In the other version of the exam, let's go see the other version of the exam. They had a very similar question. In the other version of the exam, same idea. Give me all the natural numbers that are less than or equal to 2. So of the natural numbers, 1, 2, 3, ... Which ones are less than 2? Less than or equal to 2, rather. It's just 1 and 2. So this one was 1, 2. Very similar idea. So this question was really poorly done. A lot of people, I think, forgot what the natural numbers were. There were some similar ones on the practice test. And again, this was one of the very first things we did on the first class. So maybe that's why people messed this one up. I think this one was a great question, especially when it's right next to this other one. So I tried to give you a hint by putting it next to the other one right here, which is different, what they are. A lot of people also got half marks on this one by doing something like close. So if you did something with the natural numbers, but you wrote it wrong in some way, so like a common answer was 1 to 2, like that, with square brackets, which includes things like 1.5. So that's not right, but I think you got half a mark for that. So I tried to tell the graders to be generous with that. If you think you did something close to correct here, but didn't get a half mark, and it involved the natural numbers, like you showed you knew what the natural numbers were, then you should get a half mark. So try to, if that's you, then submit a regrade request for that one. Okay, so this one was poorly done, but still better than that one multiple choice question that I made bonus. The one next to it, this one was really supposed to be super easy. This is the definition of an interval. So if I say all the real numbers that are less than something, this is the definition of the half open interval from minus infinity to 2. Minus infinity to 2, that is the definition. And possible things you could have screwed up here, you could have drawn a square bracket at over here or something like that. But this one is just minus infinity to 2, and that's the definition of the half-open interval. And it was the same idea over here. This one was a round bracket instead of a square bracket. This is the interval minus infinity to 4 with a round bracket because we're talking about less than 4 in this version of the exam. Okay, so that was this one. This one was really well done. Almost everybody got this one right. The third one is the intersection of two intervals. So in this version of the exam, it was the interval minus 3 to 1 intersected with minus 2 to 2. Again, the way to do these is to draw the number lines. So minus 3 to 1, that is one interval. Let's do this one in green. Minus 3 to 1, that's this guy. Not including, so sort of open interval, not including minus 3 and 1. And minus 2 to 2, minus 2 is here, and 2 is here. So minus 2 to 2 is this interval. Everything from minus 2 to 2, including minus 2 and 2. So this one was closed at both ends. So I drew this one in yellow. And we want all the things that are in both, right? An intersection means in both. That's everything between minus 2 and 1. So by overlapping the intervals, it's everything between minus 2 and 1, minus 2 to 1. And because you include negative 2 and exclude 1, it's like this, minus 2 to 1. That's the answer to this one. This one was also quite poorly done. And actually, there were a lot of people who wrote stuff like this. They wrote x such that x is either, or I guess they wrote and. Okay, so if you wrote this, x is in minus 3 to 1, intersect minus 2 to 2. This is one common answer we got for people here. So the question was trying to get you to do it in interval notation and try to simplify it. But I totally agree with you guys. The question was a little ambiguous. It says either set notation or interval notation. So if you wrote this, you wrote it in set notation and not interval notation, and we wanted you to write it in interval notation. So maybe this one was a little unclear. So I also counted this question, because of this ambiguity in the question, I also counted this as a bonus. So if you got this one wrong and you wrote something like this, it didn't count against you. If you did it correctly, then you got a bonus. This one was also, most people did not get a mark here. Maybe because of that. I think a lot of people also were confused about how intersections work. A lot of people, I think, just try to pattern match. So they're like, oh, when there's an intersection, it's always the first one with you do minus 3 to 2. But there is no pattern like that. So you really have to sit down and do the actual intersection. You cannot just look at these four numbers and know what they are. It depends on the details of what it is. So minus 3 to 2 is all wrong here. It's minus 2 to 1. And in some situations, it will be minus 3 to 2. So depending on how the details work out. Okay, so that's all to say the final answer is minus 2 to 1, and it's counted as a bonus because of this ambiguity in the question that was there. So next time I'll be sure to try to word it a little more specifically. And I think the other version of the exam was almost the same thing. The other version of the exam, yeah, so it was the same idea. The numbers were slightly different. It was minus 3 to 0, intersect minus 1 to 2. Same idea, draw a number line, look at where they overlap, and you'll get the answer. I won't do it again. So if you want to see the answer written, look at the posted answers. Okay, that was question 13. Question 14 and 15. These were really well done. Some of the best ones that were done on the test. Question 14, convert from degrees to radians. 45 degrees is equal to 45 degrees times, you could have done 180 to pi, or you could have done 360 to 2 pi. And you got to do it the right way. So pi divided by 180 degrees radians. And if you simplify, you get pi by 4 radians. So pi by 4. I think on the other version of the exam, they had 30 degrees or 60 degrees instead. But very well done. Question 14, most people got correct. Okay, number 15 was about this triangle ABC. This one also very well done, but I was surprised that as many people got it wrong as they did. This one is a straight Pythagoras. So you want to find the distance between A and C. How do you do it? It's AB squared plus BC squared. So AC squared is 12 squared plus 5 squared, and therefore AC is the square root. 12 squared plus 5 squared. And I even made the numbers really nice. If you put this in your calculator, 12 squared plus 5 squared adds up perfectly to the square of 13. So this is 13. Yeah, okay. So most people got this right. I saw a lot of people, more than probably I would have expected, doing things like 12 squared minus 5 squared, and then they get like 10.9 up here. And of course, we talked about this in class. You can't have a side of a triangle that's the hypotenuse can't be shorter than the sides AB. So if you did something like that, you got 0. That was worth 1 mark. Most people got that one right. In the one next to it, find the sine of the angle. That was also supposed to be very easy, and I was surprised by how many people got this right. Sine is opposite over hypotenuse, and that's all you needed to do. You found in part A, you found that the hypotenuse was 13. The opposite side is 5. So what is opposite over hypotenuse? It's 5 over 13. So that's it. A lot of people, I think this is where they lost a mark because they were too focused on their calculator. They got 5 over 13, then they started plugging that into their calculator, doing like sine inverse, sine, and eventually made a mistake and got it wrong. But it's a very simple question you can do without a calculator. Normally, I don't allow calculators on tests for reasons like this. I think more people than not lost a mark here by overusing their calculator, where if I had said no calculators, people would have been grumpy and sad, but would have got it right. So, okay. In any case, that's question 15, and that's how it works. It was supposed to be very simple, like high school trig review and nothing super crazy. A lot of people, this one was very well done, and this one was, again, pretty well done, but I was surprised by how many people got it wrong. The other version of the exam, very similar stuff. It was just 2 different numbers. And so I believe 15 squared plus 8 squared adds up to 17 squared, if I recall correctly. And so this one was 17. And the sine, once you know that this is 17, is 8 divided by 17, opposite over adjacent, 8 over 17. That's the whole question. Okay, next up, determine the slope between these points, P and Q. How did people do on this one? I think people did well on this one. Yeah, this one was super well done. You just have to use the slope formula. So y2 minus y1 over x2 minus x1. In this case, it is 9 minus 1 divided by 8 minus 6. 8 over 2, which is 4 in this version of the exam. In the other version of the exam, very similar, and I think it works out to 3. Let's do the other version. So this one was 10 minus 1 divided by 8 minus 5. 9 divided by 3, which is 3. They were both 3. Now I thought they were different. Oh yeah, okay, 3 and 4. Okay, good. Okay, so very well done on that one. Not much to say about that. Okay. The next question, question 7. Find the intercepts, the x and y intercepts of x squared minus x minus 12. The y intercept, I think this might have been the best done question on the exam. Plug in x equals 0. Almost everybody got it. If you plug in x equals 0, these x's go away, and you just get y is negative 12. So negative 12. What are the x-intercepts? For that, you have to factor it. So you have to come up with 2 numbers that multiply to 12 and add up to negative 1. The numbers, I guess, are 3 and 4 here. So x squared minus x minus 12 is x minus 4 times x plus 3. And then you have to not mess up the signs, 4 and negative 3. So just factoring and finding the intercepts, just like the example from class. I think a lot of people maybe lost a half mark here for missing a sign or something like that. But almost everybody did well on this one. And the other version of the exam has very similar thing with a different equation. So the y-intercept is what you get when you plug in x equals 0. It's minus 10. It's just the number on the end here. And the x-intercept, you factor it as x minus 5 times x plus 2. So it's negative 2, 5 are the x-intercepts. So you could have written this as in a number of ways. You could have also written the coordinates out, but as long as you had negative 2 and 5, you should have gotten that mark. Okay, so that was actually relatively well done. Lots of half marks. Okay, question 8, find the domain. This one, a lot of people struggled with. Maybe people were low on time, but almost everybody left early, so I don't think that was what happened. Maybe people gave up on this. Some people just looked at it and took a guess like 2 to 8, which is not right. And all you got to do to remember for this question is that when you have a square root, the thing under the square root has to be greater than or equal to 0. So under the square root greater than or equal to 0. We did a lot of problems like this in class. In this case, it's 8 minus 2x is greater than or equal to 0. Of course, if you wrote 8 minus 2x greater than or equal to 0 here, like you wrote this is an equation that's not set, right? We want the domain of f, and it says in the question expressed as an interval. So you have to take this 8 minus 2x greater than 0 and massage it into what that means as an interval. I would add 2x to both sides. 8 is greater than 2x. So if 8 is bigger than 2x, then 4 is bigger than or equal to x. So it's x is less than or equal to 4. As an interval, the set of things where x is less than or equal to 4 is minus infinity to 4. So this is the correct answer, minus infinity to 4. That's what you'd have to do for full marks. If you did something like this, you should have at least gotten 1 out of 2 on this question. Or as long as you were on the right track, if you had this kind of stuff, you should have gotten some part marks. If you didn't, then you should submit a regrade request. I told the graders again to be as generous as they could be, but it's very possible they missed something. So check that one carefully if you didn't get a part mark there. The other version of the exam, I think, had a very similar question. It was 6 minus 3x. So if you do this, it's 6 minus 3x is greater than or equal to 0. So this, again, the stuff under the square root has to be greater than or equal to 0. And that means that 6 is bigger than 3x, also known as 2 is bigger than x. And if 2 is bigger than x, x is less than or equal to 2, that's the interval from minus infinity to 2. Okay. Question 9 was very well done. Is the graph of x squared plus y squared the graph of a function? X squared plus y squared equals 9 is a circle. So you're supposed to look at this and say circle, or in your brain, notice it's a circle, and a circle, the whole circle, is not a function. If you said yes, some people got confused by, on the practice test, there was a similar problem where it was a function. That was the function. Y is the square root of 9 minus x squared. And that is different. X squared plus y squared equals 9, and y equals the square root of 9 minus x squared are different for this reason that square roots are always positive. So y equals square root of 9 minus x squared. It's just the top half of a circle. In this question, we're talking about the whole circle. So these are different. Maybe I should do them in a different color. This is different. So it is not a function. So people did very well on that for the most part. In the explanation, people did not do so well. A lot of people had good answers that said, like, it's a circle, therefore not a function. So circle, therefore not a function. Okay, so if you wrote it's a circle, therefore not a function as your explanation, this is unfortunately not correct. And the reason is we want to explain why it's not a function, okay? Like the whole point of this thing, give a 1 or 2 explanation of why. Why is it not a function? That's what we wanted here. So if you wrote it's a circle, therefore not a function, you got 0. We want to see why. Some people wrote by the vertical line test, therefore not a function. Okay, and this is great. This is good. This answers why. But we actually really wanted to see, and this was in the instructions, your answer must refer to specific x and y values. So I wanted specifically, by the vertical line test, it's not a function, specifically which vertical line and where is it intersecting. That's what we want to see. So if you wrote this, I think you got 0.5 out of 1 mark. For full marks, to get the full mark, you had to give specific x and y values. So for example, you could have done when x equals 0, the vertical line at x equals 0, y equals 3, or y equals minus 3. That would be the full mark. 1 out of 2. 1 out of 1. So the 2 points in this question, 1 point was for the yes or no, and 1 point was for your explanation. And a lot of people got either half a mark or 0 marks on the explanation because they weren't answering the question. in retrospect, looking at it and seeing how people did, I think I wasn't clear enough in the question on what I was looking for. And so I'm counting this one as a bonus as well. This one is a bonus. So if you did, you wrote circle, therefore not a function, you got 0 marks, but it won't count against you. This whole question is counted as a bonus. If you wrote the proper answer we were looking for that has specific X and Y values, then you got a bonus mark, and good for you. So next time I will be extra crystal clear on what I'm looking for. I think a lot of people did not understand we were looking for the real reason why, not just what is the answer. What is the answer was the yes or no. Here we wanted why. So that's why I'm counting this one as a bonus. Okay, last 2 questions on the exam had you drawing pictures. And one of them was really well done, and one of them was less well done. Let me see how people did. Okay, yeah. So this one, people did great. Draw a function with a vertical asymptote at x equals 2. X equals 2. And a horizontal asymptote at y equals minus 3. Here's y equals minus 3. And all you had to do was draw a function that has these two as their asymptote. Almost anything would work. I think the most easiest thing to do would be something like this. Some function that looks like that, like a reciprocal type function. That would be perfectly fine. You could go really creative and do one of these weirdo functions. Oh, I guess that one doesn't have a vertical asymptote in the right place. So you could do a function that goes like this and then comes back down like that. It's okay to cross the lines as long as it's kind of hugging the 2 vertical and horizontal lines. You got the full marks. So almost everybody got 2 out of 2 on that one who tried it. If you drew a non-function or something, then you got it wrong. Question 21, the average was like 1 mark out of 2 on this one. And to get full marks, you really had to do all these transformations correctly. So part of the transformation was shifting it. That's the x plus 3. This is a shift. And it's 3 units to the left. So the plus 3 means 3 units to the left. The minus 2, this is a flip, a vertical flip, and stretch by 2. By a factor of 2. So if you do these, things get shifted over by 3 to the left. So this thing, which is at x equals 3, gets moved that way to here. This one, which was at x equals minus 1, goes 1, 2, 3 units all the way to here. The vertex, which was here, goes 1, 2, 3 units that way to here. So that would be just the shift, would be this, right? And then you had to flip it upside down and stretch it by a factor of 2. So flipping it upside down would look like that, right? That's just flipping upside down. And to really get the full marks, you had to also stretch it out by a factor of 2. When you stretch it by a factor of 2, the vertex goes down from -1 to -2. So the correct final answer looks like that. That is the correct final answer. You had to get all of those things to get the full marks. Almost everybody got some part marks here. 1.5 was very common. 1 out of 2 was also common, but pretty well done. On the other version of the exam, it was the exact same concepts. You had to do the exact same 3 things, but the numbers were different. Let me find the other version of the exam here. Yeah. Okay. So here it was x minus 1 is a shift 1 unit the other way. So shifting 1 unit to the right. So this goes to here. The vertex moves over by 1 to here. And this moves over by 1 to here. And then you flip it upside down. So the after you flip it, it's like that. And then you have to stretch it this time by a factor of 3. So the vertex, instead of being at +1, is at 1, 2, 3 up there. So the final answer was like that. Whoosh. Okay. So same exact idea, different numbers, same parabola function. It was upside down. Yeah, this one was almost exactly the same. This question was almost exactly the same. Okay, so let me see how we're doing. That is it for going over the midterm. Hopefully that helps. Yeah, if you have any questions about it, feel free to reach out to me either at office hours or on Campus Wire. There is a regrade form. If you think that there was a grading error or the graders missed something, then you can submit that, and then I will personally look at them. So hopefully that helps you guys. And yeah,